Hi, I'm an old guy and I do maths. Today what we're looking at is the gradients of linear functions and tangents. And it's going to spoil the surprise, but the fact is they're related. Um, the gradient of a linear function is equivalent to the tangent, or equal to the tangent of the angle that that line makes with the x-axis. And it's clearly expressed here. So what we have is we have a function y equals 2x minus 2, which I've graphed here, and I've got some points of interest, as they say. So this point here is 3, 4. This point here is 3. This point here is 1, 0. And we have this angle in here. Now, we know that the gradient of this is 2, so let's just make a note of that. And how do we find the gradient? Well, in the roughest of ways, the least sophisticated of ways, it is rise over run. It is this distance divided by this distance, which, if you've done any trigonometry, you will realize is also a tangent ratio. It is opposite over adjacent. And so if I take this this drawing here and express it clearly as a triangle, this becomes a little more obvious. Our gradient is 4 over 2, m equals 2, and we can obviously find the angle alpha from that. So let's go ahead and do that. So I've just popped that into my calculator, and the angle that we get is 63.43 degrees. 63.43 degrees. And you'll notice that I skipped a step. I didn't put 4 divided by 2 in here. I just put 2 because it's fairly obvious that 4 divided by 2 is 2, and it is also our gradient. So there is an example of the relationship between these two things. So many things in maths are connected. And the whole reason for doing this video, despite the fact that if you've watched this now, you might think that it's glaringly obvious that this relationship exists. It's usually just passed over very quickly in maths classes, and suddenly you're asked a question pertaining to this, and a lot of head scratching goes on. Now let's have a look at an example, very similar equation with one significant change. So here we are operating with a negative gradient. M is equal to -2, which I think it's reasonable that you can understand. So this distance here is 4, this distance here is -2. We've gone -2 in the direction of the x-axis. And so we get a gradient of -2. Now, what we're actually looking for is this angle here. In order to find this angle, we need to find this angle. We actually go about finding this. Now, I need to explain that a tiny bit. Why do we do that? Well, it comes back to a thing called the unit circle, which hopefully you're familiar with. I think that if you're getting to the point where you're discussing gradients equaling the angle of incidence with the x-axis, I think that you will have dealt with the unit circle. Anyway, all values of sines, cosines, and tangents are positive here. Only sines are positive here, and what we're looking at with this drawing is we're looking at something that looks like this. Our triangle, which is formed with the x-axis, looks like that. So we're firmly in the location where tangents are negative. Now, if we look at this, it's very easy to see that this has got a negative gradient. However, if we extract this triangle and draw it as we did with the previous example, we've still got we're dealing with magnitude here. So this is 4 and this is 2. They're both positive. And what we will do when we find this, the value of the angle that the tangent creates, is we'll find this. We won't find this. So, in fact, what the negative gradient tips us off to, what this tips us off to, is the fact that we're looking for something potentially in this quadrant of the unit circle, and therefore our tangent will be negative. We will work this out, but we are actually finding this angle. So when we talk about the angle of incidence with the x-axis, we're always talking from the first quadrant around to wherever the radius in the unit circle is, or the hypotenuse of the triangle, from the nearest x-axis. And in terms of linear equations, our radius is going to be either in this quadrant or this quadrant when we look at a linear equation described like this. Okay, well, it's the same old, same old. We'll find the value of this, and it is exactly the same. However, this is what is 63.43, and what we have to do to find, this is 64.43. What we have to do to find this angle is subtract that from 180. So 180 minus 63.43 gives us 116.57 degrees. So the angle that this makes with the x-axis working from here is 116.57 degrees, and that is described by the gradient of this thing being -2, as opposed to our previous example here, which was +2, and there was no question about the angle that we were looking for. Okay, now I hope this alerted you to a question or two that you might be asked. I hope it was useful, and if it was, please like and subscribe, and I'll see you next time. Thanks. Bye.